Hello and welcome to the Quiz 2 solution set. So our first problem, we had an absolute value 1, absolute value of the difference between 3x and 8, decreased by 12, was worth -5. So this one, we notice the absolute value is not by itself, so we fix that before we do anything else. So we'll add 12 to both sides of the equation. So absolute value of the difference of 3x and 8 is worth +7. Absolute value equals a positive. There's two ways for that to happen. So we set up our two equations. The argument could have been a -7. Union that up with the possibility that the argument was a +7. We're adding 8 to both sides. So 3x is worth 1, multiplying both sides by a third. So x is a third is one of our possible solutions. That tells us we're going to be doing an Euler diagram. Our second equation, we also add 8 to both sides of the equation. It's 3x plus 0 turns into 3x, 7 and 8 turns into 15. Multiply both sides by a third. So 1 times x is x. X is worth a third of 15, which is 5. So we get to keep the 5. And the 1/3 goes into a sketch of the real number system in the Euler diagram. So integer domain, we keep the 5. The 1/3 is outside the integer domain. Problem 2, a little bit shorter. Absolute value of the difference of x and 8 decreased by 12 is -5. This is a minus here. This is my absolute value. Like the previous one, we need to get the absolute value alone before we do anything else. So we'll add 12 to both sides. Absolute of the difference of x and 8 is worth +7. Two ways for that to happen. So we set up our two equations and solve. And you can finish it up from there. So that one we ended up getting to keep both solutions. Problem 3, another absolute value problem. Absolute of the sum of x and 4 decreased by 8 is worth -8. Absolute value not alone, so we fix that. So absolute difference of x and 4 is worth 0. This time there's one way for this to happen. So we set up our one equation and solve. Make sure that you are showing your work. This is in our domain, so we get to keep it. Problem 4. Now we're solving a quadratic. X squared minus 3x is worth 10. This being a quadratic, we want to make sure one side is worth 0. We don't have that yet. So we subtract 10 on both sides. Again, make sure you're showing it on both sides. So x squared minus 3x minus 10 is worth 0. So we want a product of -10, sum of -3. So 1 and -10, right product, wrong sum. 2 and -5 works out. And this is a coefficient of 1 on the square term. So we can do the fast factoring. X plus 2 by x minus 5 is worth 0. Multiplication problem ending in 0, just set one factor at a time equal to 0 and solve. So x plus 2 is 0, or x minus 5 is 0. And you can finish out from there. We have two elements in our solution set for that one. Problem 5, a little bit shorter than problem 4, since we had one side already set to 0. So this time we want a product of -35, sum of -2. So 1 and -35, no dice there. 2, 3, and 4 are not factors. 5 and -7 get the job done. So x plus 5 by x minus 7 equals 0. we set up our two equations. And you'll get two elements in your solution set from there. Problem 6. This one kind of made it obvious which of you were using apps and other things to try to get to some solutions. This one was pretty easy to tell that on. Okay, so we're setting one side equal to 0. Now we're multiplying to a positive 24, having a sum of negative 11. So either plus plus or minus minus. The fact that we're adding to a negative tells us it's minus minus. And negative 3, negative 8 will do both jobs. First two terms, I can factor an x. Second two, we can factor a negative 4. And we're still equal to 0. So 2x minus 3 by x minus 4 has to equal 0. Set up your two equations and solve them. On this one, we got to keep one of our two solutions. So the other one would have ended up in an Euler diagram. So our solution set, we just have a 4. And there would be then an Euler diagram. So I'll let you finish the Euler diagram on your own as well. Seven, we're looking for excluded values. So we have x plus 7 over x squared plus a 4x minus 21. So we want to factor that denominator. Multiplying to negative 21, adding to a positive 4, so one of each signs. Big absolute value gets positive. So x plus 7 by x minus 3. So the two values that would make us divide by 0 are the two excluded values. So x cannot equal a negative 7, x cannot equal a positive 3. So we're not saying x equals negative 7, x equals 3. Those are the two values x cannot equal. 8, same instructions. We're looking for excluded values. We have a 3x minus 2 upstairs, 3x squared minus 2x minus 16 downstairs. So we'll hang on to that numerator. The denominator, we're multiplying to a negative 48, so 3 by negative 16, adding to a negative 2. So 1 and negative 48, no. 2 and negative 24, no, and so on. 5 doesn't work, and 6 and negative 8 are the winning combination. So 3x squared minus 6x plus 6x minus 8x and minus 16. So we grab a 3x from the first two terms, a negative 8 from the second two terms. So we have 3x minus 2 over x plus 2 by 3x minus 8. So as far as excluded values, x cannot equal a negative 2. X cannot equal a positive 8/3. Both of those would have us dividing by 0. Problem 9, we do both excluded values and simplifying. So x squared minus 8x plus 12 upstairs, 4x squared minus 27x plus 18 downstairs. So 4 by 18, 72. We're multiplying to a positive 72, adding to a negative 27. This was another one that was sort of a dead giveaway if you were using an app. So let's see. We're multiplying to a positive, so either plus plus or minus minus. The fact that we're multiplying to a negative says minus minus. As far as the Numerator, we're multiplying to a positive, adding to a negative as well, so everybody gets a negative. And -2, -6 is our combination. So x minus 2 by x minus 6 upstairs. Downstairs, we have to do the grouping. So 4x squared minus 3x minus 24x plus 18. And we just hang on to that numerator and do our grouping stuff in the denominator. So we can pull an x from the first two terms. We can pull a -6 from the next two terms. So we have x minus 2 by x minus 6 over 4x minus 3 by x minus 6. So our excluded values, x can't be worth 3/4, x can't be worth positive 6. And as far as simplifying this, since x is not worth 6, x minus 6 over itself is a 1. So 1 times x minus 2 is x minus 2. 1 by 4x minus 3 is 4x minus 3. So there's our simplified version. 10, same instructions as number 9, excluded values and simplifying. So upstairs we have an x squared plus 8 times x plus 12. So everybody's positive upstairs. Downstairs, x squared plus 2x. So we're multiplying to 12 again, this time adding to a positive 8. So positive 2, positive 6 will do that. Denominator, we can pull a GCF of x. So our excluded values, x can't be worth 0. X also can't be worth -2. The two things that would make me divide by 0. And as far as simplifying it, if I cancel the x plus 2's, I have x plus 6 at the top, just x at the bottom. And that's as far as I can go. X is a factor here. X is not a factor of the top. X is a term at the top. Uh, 11, we switch gears a little and we look for the LCD. So x minus 8 over x squared plus 16x, 6x, my apologies. Plus 6x plus 9 and x plus 9 over x squared minus 5x minus 24. So first one, I'm multiplying to 9, adding to 6. 3 and a 3 will get the job done. Second one, multiplying to -24, adding to a -5. A positive 3 and a -8 will do those jobs. So our LCD, because of that first fraction, I need 2 factors of the x plus 3. Because of the second fraction, I will also need an x minus 8. So it's a common mistake there if you're missing the second factor of the x plus 3. This one needed 2 of them. 12, we're solving. So we have x thirds plus 3/5. It's worth 4/15. We have no variables in the denominator, so we have no excluded values. LCD here is 15. So everybody gets multiplied by a 15. So 15 thirds is 5, so we have 5x. 15 fifths is 3, so plus 3 by 3. 15 fifths is 1, 1 by 4 is 4. 5x plus 9 is 4. And you go from there. So on that one, we had one element in our solution set. And because there were no excluded values, we did get to keep that one solution since it also landed on the integers. 13, now we do have some excluded values. So here, excluded value, x cannot equal 4. LCD is x minus 4. So once again, everybody gets hit with the LCD. Every single term gets multiplied by the LCD. That includes things that don't look like fractions. Since x isn't worth 4, here's a 1, and here's a 1. So 3x is worth 2 by x minus 4 plus 12. So 3x is 2x minus 8 plus 12, and just hit your like terms. So we'll subtract 2x on both sides. So x is worth 4, but excluded value, x can't be worth 4. So this one we walk away empty-handed. 14. If x plus 14 over the difference of x and 2 is worth 7x over difference of x and 2 plus 1. This is another one where telling which of you were using apps was pretty simple, pretty straightforward. So our excluded value, x can't be worth a 2, otherwise we're dividing by 0. Our LCD, the only denominator we've got in this is x minus 2, or the trivial over 1 that we can use. So everybody gets hit with our LCD. We have x squared minus 2x plus 14. So the x minus 2 over x minus 2 is worth 1. It's worth 7x plus x minus 2. So distributing the 1, you just get the x minus 2 back. So x squared minus 2x plus 14 is worth 8x minus 2. This is quadratic, so we'll set one side to 0. So I'll subtract 8x on both sides. I will add 2 to both sides. So x squared minus 10x plus 16 is worth 0. So I'm multiplying 16, adding to negative 10, x minus 2 by x minus 8 will do both jobs, and we're still equal to 0. X minus 2 is 0, or x minus 8 is 0. Solve those linear guys. So x could be 2, or x could be 8. We said at the beginning, though, x can't be worth positive 2. Throw that guy away. We'll keep the 8, though. We're back to our square root days. So is the absolute, or is the square root alone? No, it's not alone, so we fix that first. So we'll subtract 5 on both sides. So x minus 5 is worth the square root of the quantity x plus 7. Now that the square root is by itself, undo the square root by squaring both sides. So x minus 5 by x minus 5 is worth x plus 7. So if we have an extraneous solution, it'll work for all this stuff. It won't work in the original. So we have x squared minus 5x minus another 5x, so minus 10x, and plus 25, last times the last. It's worth x plus 7. So again, a quadratic, we're setting one side to 0. So I subtracted x and 7 on both sides. So x squared minus 11x plus 18 is worth 0. We're multiplying to a positive 18, adding to a negative 11. Negative 2, negative 9 will work just fine. So either x minus 2 is 0 or x minus 9 is 0. Add 2 to both sides. X could be 2, or add 9 to both sides. X could be 9. The thing that was new in problem 15 that we didn't have to do earlier is to make sure that it works. So we check, is 2 worth the square root of 2 plus 7 with a plus 5 outside? 2 possibly equal to square root of 9 plus 5. 2 does not equal to 3 plus 5. we'd have 2 on one side, 8 on the other. So we have to discard that solution. Checking out the 9. 9 possibly equal to square root of 9 plus 7 with a plus 5 outside. 9 possibly equal to root 16 plus 5. 9 possibly equal to 4 plus 5. 9 equals 9. We're happy with that guy. So we keep the 9. And we have our Euler diagram for the extraneous one. So 9 worked for both. 2 worked for only one of them. So inner is the solutions to the original. Inside is the solutions to x plus 5. X plus 5 is worth x plus 7. And picture that on the same line where it should be. Uh, 16, if you were paying close attention, was a quick problem. 1 is worth 8 plus square root of x minus 3. Square root wasn't by itself, so we fixed that first. So negative 7 is worth square root of x minus 3. Square root equals to a negative. We go to empty set on that guy. Remember, the square root represented the principal root. 17 root x minus 6 is worth 4. Radical was by itself. Undo the square root by squaring both sides. So x minus 6 is worth 16. Solve that linear. So x is worth 22, and see if we get to keep it. So 22 minus 6 possibly equal to positive 4. Root 16 possibly equal to 4. 4 equals 4. We do like that. So we keep the 22, the only proposed solution. 18. Solve for C. So we had n divided by A plus n divided by B equals R divided by C. So our excluded values, A can equal 0, similar for B and C. Our LCD for the problem would be whatever A times B times C is. So everybody gets our LCD. Cancel our 1s. So n times b times c plus n times a times c equals r times a times b. We're looking for the c by itself. This time they were nice to us. They gave us all the c's on the same side. So we'll just use the GCF. So factor out that GCF using the distributive property. Actually, this is just a common factor, not necessarily the greatest common factor. So C is worth RAB over NB plus NA. So the letter they asked for is by itself, and it doesn't appear on the other side. We've solved it. And our last one here. We're solving for M. And here we're assuming Z is not negative. So square root is by itself, so we undo the square root by squaring both sides. So 5r squared minus m is worth the same thing as z squared. We're looking to get the m by itself, so I'll subtract 5r squared. So minus m is worth z squared minus 5r squared. Divide both sides by -1, so m is worth minus z squared plus 5r squared. They asked us to get m by itself. We have m by itself. Okay, so that should give you enough info to do some reviewing for the test, which will be on Thursday.